All right, so first part of this homework will be on increasing and decreasing. We'll talk about extrema and how to find out on your calculator, and then we'll do the average rates in a minute. All right, look at this lovely graph right here that I just did. And the way you read a graph is from the left to the right, just like you read a book. You read a book from left to right. So just watch my pen for a second. My pen is doing what right now? Increasing or decreasing? Increasing up until here, right? Right about here, it does what? Decreases. Then what does it do? Increases. Okay, so you all know that that the pen is going up and then it's coming down and then it's coming up. So you all know when it's increasing. What you have to do is tell it to me in an interval notation, and you have to find that critical point. There is some point right here that it's going to start switching from an increase to a decrease or a decrease to an increase, okay? And the way we do that is we only do increasing and decreasing intervals along the x-axis. That's only when we do it. We don't do it to the y's. We only do it to the x-axis. So right about here, in this section right here, bear with me on my highlighter, you all agree that was increasing, right? So you would say, okay, Mrs. Setta, it's increasing from where? Well, from negative infinity on the x up until what point on the x did it increase? On the x, not the y, not how tall it was, on the x. What's that point right there that I highlighted? To -2. And by the way, you don't put brackets here. It's just an interval notation along the x. So we're just saying it's just notation for increasing or decreasing. Then you all agree that my pen switched from an increasing to a decreasing. Would you agree? Up until about here. So again, if I'm using my highlighter, on the x-axis, it went decreasing from -2 to where on the x? 0, right? And then you agree right after that, it increased again? Yeah. And so what would be that interval notation? 0 to infinity. So notice something with me. You always start at negative infinity. You always end at positive infinity. Yeah, go ahead, open that for me. And then do you notice how it's repeating numbers within here? -2, -2? Okay. Go ahead. 0, 0, but you always start at negative infinity, you always end at positive infinity. So just to write this down, increasing or decreasing, Number one, it's always along the x-axis. Please don't tell me the range. I have so many students give me like, oh, it's at 2. No, guys, it's at -2. It's at the x-axis value. You always give it to me in interval notation. And please always read your graph from left to right. Okay? So this would be the first part of your homework that you'll be doing tomorrow in class, really. They'll give you a picture of a graph. They'll ask you, where is it increasing? Where is it decreasing? So just start on the leftmost part. Trace it is what I would suggest. And then once you feel you've changed, that would be then a decrease or an increase depending on where you're going. Now, those points are important, the points that we just talked about. Again, I told you, those are called critical points, very important when we hit calculus. But they also have special names, and I think you remember this from Algebra 2. But if you have a picture like what I just showed you, this point right up here, it's a high point on the graph, but it's not the highest. Would you agree? It is a high point, but it's not the highest. The highest point is off up here. But in mathematics, when it's a high point, but not the highest, it's called a relative max. If it was the absolute highest, that would usually be a parabola, an upside down parabola. We would call that an absolute max. This point right here is a low point, but it's not the lowest point in the graph. This is called a relative min. And then just for future use, we're going to get there. We can have points in our graph where there's not really a change from increasing to decreasing. We actually change from increasing to increasing, but there's definitely this like little dance in the middle. And that is what we actually call a point of inflection. Again, very important when we hit calculus to know where those points of inflection are, where those relative max and mins are. And by the way, relative max, relative min, absolute max, absolute min, those are all given a name in mathematics called extrema. Extrema is or are critical points where the function changes from increasing to decreasing or decreasing to increasing. Critical points where the function changes from increasing to decreasing or decreasing to increasing. Those point of inflection points, we'll deal with them a little bit later. So now, the second part of the homework tomorrow will be to find those extrema. And I think you all remember how to do it. I remember the last class, the other class remembered how to do it. Let me just give you an example of how to find it, and you get to find this all in your calculator. Thank you. Approximate the extrema for the function f of x equals 2x cubed minus 4x squared minus x plus 5. Two x cubed minus 4x squared minus x plus 5. Put that in your calculator, please. I want to make sure you all know how to do this. 2x cubed you can obviously graph it. Looks something like that. Okay. So there are, how many critical points do you see on this graph? 2 here and here. Okay, there's a high point, not really the highest. There's a low point, not really the lowest. So this is a relative what? What's this one? Max and relative min. It's very important that you know the difference, because here's what we're going to do. Your calculator will find it as long as you type it in correctly as to what it is. If you said, oh, this is my relative min, Mrs. Setta, then your calculator will give you the wrong answer, FYI. So this obviously is a relative max. So the way you do this, and if you don't remember, I'll write it down for you. You hit second calc, not 5, enter. It's second calc, and then you hit max or min depending on what it is. Okay, so I'm going to do this point first. I'm going to hit second calc, and that is a max. Don't hit min. It's going to ask you 3 questions. It's going to say left bound, right bound, guess. Left bound, right bound, guess. So you actually move your cursor to the left of the dot or left of the bump and hit enter. You should see a little darkened arrow come up. Then you move it to the right of the bump. Hit enter. So what you're telling the calculator is now, hey, find a max within this window. And once you get up this frame that says guess, hit enter again. So I have a maximum at negative 0.12, and just write it out for me, this point right here. This would be a relative max at negative 0.12, comma 5.1. All right, now let's try to find this one. Same thing. This one, though, is a min. So you hit second calc, min, go to the left of it, hit enter anywhere, go to the right of the bump, hit enter, Once it comes up, guess, hit enter again. And I got 1.4, comma 1.2. Is that what you all got? Easy, right? Easy peasy. I mean, this isn't hard stuff. Done. That's what you'll have to do on the second part of your homework tomorrow. So again, first part is this idea of where is it increasing, write it in interval notation. Second part would be approximate the extrema. You can do that with the calculator, totally easy. This third part and final part is actually my favorite, but it's kind of disappointed my students in calculus don't remember. It's called average rate of change. Average rate of change. Honestly, I'll give you a big clue as what you're doing right now with average rate of change. In calculus, it's called the derivative. That's what it is. You'll come to find out. That's all it is. And it's actually really easy. But my precious lambs don't remember it yet. Let me give you the actual long definition for it. It's not that hard, but I kind of want to talk about it because there's some math words in there that you haven't seen in a while. The average rate of change is the slope of the secant line through 2 points on a graph. The slope of the secant line through 2 points on a graph. Okay, don't confuse this secant with the words tangent, cotangent, cosine. Do you remember doing all that trigonometry last year? Okay, this is a different secant. Do you know what secant is? Do you remember it from geometry? If you have a circle and you have a secant, do you know how many points that secant cuts through? 2 points. So if I give you a graph, I don't know, with some curve like that, okay, and I want you to find the average rate of change, I'm asking you to find a secant line. I'm asking you to find at this point A, and then at this point B, I want you to find the slope of this line right here. This is your secant line. I'm actually asking you for the average rate of change. Let me get, just for example, okay, if you were to drive in your car right now, and you get in your car and then you get onto 485 and I'm asking you, okay, what's your average rate of change from, I don't know, say time at, you went after you've been driving for 30 minutes compared to after you've been driving for 2 hours. Wouldn't you agree your speed would change during that time? Well, I want to know what the average rate of change is. So I just take these 2 points and I find the slope of it. I find really their difference. What's the y value if this is A? What's the y value here? Does anybody know? What would we call it? If this is the function f of x, do you know what it would be? You're going to blow your mind. It's f of A. Right? If this was 3, wouldn't you plug 3 in? Okay. If this is the point B, what would be the y value? F of B. Wow. God bless you. Well, this is actually how you find slope of a secant line. Anybody remember the actual old school formula for slope? What's the old school formula for slope? Y2 minus Y1 over X2 minus X1, right? Well, average rate of change, the slope is the following. This is the formula. F of B minus F of A. Hey, that's Y2 minus Y1 over, what would it be over?
B minus A.
Exactly. That's the formula you're going to use tonight or tomorrow. So let me do one example and then I'm done. Find the average rate of change. So what I'm trying to get in your head, y'all, is these words in mathematics, average rate of change, all that means is slope. Average rate of change, slope. That's what it means. Find the average rate of change of f of x equals negative x to the third plus 3x on the interval -2, -1. Find the average rate of change of f of x. So here's this curve that I got. I want you to find it at -2 and -1. That's what I'm asking you to find. Okay? So in my formula, just look up here again. What do you think these two numbers are? Just take a guess. It's on the x-axis. So what do you think they would be in this formula, though?
B and A.
Wouldn't they be the b and the a? Wouldn't you agree? Okay, so I'm going to call this my b and that one my a. Does it matter? Not really, as long as you do your y's correctly, but I'm just going to do it A and B, okay? Now, how do I find f of b? What do I have to do?
Plug it in.
Plug in the b. How do I find f of a?
Plug it in.
Do you know that your calculator will do plug it in, plug it in? What? Huh? Go to y equals, type in -x cubed plus 3x. Set your table to start at 1 and make sure it goes up by 1. Don't make it go up by 0.01. And now just go to your table. Well, actually, I want to go to -2. It doesn't matter, though. But look, hey, at -2, what is your y value?
2.
Your calculator just did f of a for you. Your calculator just did f of b. Yes? Do you not realize what your calculator is doing? Because whenever we had to do that on the test, when it said find the h of -1 on the last quiz we had, you could have just let the calculator do it. But whatever. You do what you got to do. You work hard. But Miss Teddy, you showed work. I did. You did show work. Good job. So -2, -1, I have a 2 and I have a -2. And all you have to do with this is find slope. That's it. y2 minus y1 over x2 minus x1. That's all you have to do. What? So let's find out what the slope is. F of b minus f of a over b minus a. So -2 minus 2 over your x's. -1 minus a -2. Would you agree to that one, right? You have to change the sign there. So what's that become? What's -2 minus 2? -4 over. That's your slope. That is your average rate of change. -4. I wish, I hope, I'm going to ask them, actually, my calculus students, if they remember what this was, because that you have just found a derivative. You have found a huge, huge thing in calculus, which is called derivative. It is just slope. It is slope of a line. That's all it is.